Our recording. Okay. So last meeting we discussed the story about Alan Turing. Oh, I'm sorry, what happened? Talagang ganito yung Dagger at this time. It goes in and out. About Alan Turing, ENIAC, no, and the IAS. Now we have compared the IAS, no, and ENIAC. Okay. The next, however, there's no programming, no, information regarding ENIAC. Although from the description, no, of the different sources, no, in the web and the different textbook, the analytical engine is basically uh, it is a decimal computer, no. No, sorry, this the ENIAC, no, the electronic numerical integrator and calculator. ENIAC is basically a decimal computer, no. It's a decimal computer, so it's very much like the analytical engine. Okay, it's fixed point decimal. It's not stored program, no. So yeah, there's a big difference between, although later in 1946, no, because this was invented 1943, the inventors Presper Eckert and John Mockley came up with a second invention called EDVAC. Now this is like an IAS. The EDVAC was not considered to be predecessor or a descendant of the IAS because it was developed almost simultaneously with the IAS. It was released in 1946, okay, after the war. So anyway, the main feature that is found in ENIAC is the accumulator. Do you follow? So instead of using registers separately for ingress and egress, which means input and output, accumulators are used. Accumulators are registers which can be used both for input and output. Okay? Any questions so far? No? So, ganon. That's the main opinion. I've encouraged you to look at the videos relevant to ENIAC. No? There are interesting stories which you can do during your free time. The ENIAC documentary. Okay. And then we have introduced the IAS. So the IAS is a computer short for Institute of Advanced Sciences in Princeton College. Okay. Remember, this is the same school where Alan Turing did his PhD in math. No? It's also the same school where the IAS was invented by John von Neumann, who's also a mathematician and physicist, no, and inventor. No, he invented the IAS computer. Before we look at the diagram, let's look at the. No, that's a problem. May problem talaga itong Okay, the IAS machines. Nawala na. Maybe I'll use another browser. No, I don't know why it's like this. Bakit ganito? I have a problem with my screen because I have just changed monitors. Check this first. No? Hirap. I can't connect to Daigler. I'm not sure why. No? Let's use a different browser. What do we have? Yeah. Let's try again. Wala. What browser do we have? Internet. Microsoft Edge. Okay. Edge. Sorry, I can't ano. Let me just Google my source, no? Because I can't seem to connect to. No? Are we still online? I think so.
Yes, sir.
Yes, I'm connected to Sky Cable. Is there any problem with Sky Cable today? I didn't have any problem with Sky Cable ever since, no?
Hello, sir.
Ha?
May
Problema
issue
bang
yung
Sky?
Sky Cable with Diagler, sir.
Ha?
May issue ang Sky Cable with Diagler.
Yeah, you changed the, no, I was told to change the IP address. I've changed it already. Do you know how to fix that one?
We can try, sir.
How do you do that? Is it the, no, DNS?
Yes, sir. Baka hindi lang na-change. Baka
Yes,
problematic pa rin yung DNS na yan.
I've changed it already. It's supposed to be 8.8.8.8.
Sir, maybe you can try 1.1.1.
Ha? Bakit nagkaganon, no? Because I used to have to, okay. I used to connect this somewhere else, no? Let's have changed this to, no? Excuse me a while, no? Because I'm going to change, if I'm going to change my IP address now, I'll be cut off from Zoom. Okay, so
Ay,
yeah,
hindi, sir. Yung sa DNS lang po yung i-change.
sandali lang. Yeah, we'll try anyway, no? Where's the DNS server? Yeah, because this DNS server comes from my router. Let's try to find out, no? Kaya ito. Anyway, if you're no, then we'll just plug in again, okay? I'll just go right back. I've changed this before, maybe because I've changed my, you know. So yeah, 8.8.8.8 should be 8.8.4.4. Let's check. Let me check. Yeah, it's changed now, no? Okay. Regular. I didn't have the okay. So we're okay now. I didn't have this problem this morning, no? In fact, I've changed this already before, but something happened, no? It went back to its, maybe it changes every time I reset, reboot. Okay, that's why I had to change it every time we start. I'll have to check the next time. Let's look at the IAS machine. No, this is the instruction set. Can you see that? Is it large enough or do I have to enlarge it? Hindi na siguro, no? So, this is like the IAS computer, if you look at the instructions, it's very much like the analytical engine. There's load and store. Do you follow? Okay. But this time, this is stored program concept, which means that whatever program you write will not run from the deck of cards or from the input device. So what happens is uh, the program is loaded from the deck of cards by batch, and then they are processed instruction per instruction from memory. So the main difference is in the analytical engine, the commands are taken. The commands are taken from the card reader one by one. Okay, and the variables are taken from memory. The problem with that, if you have a slow input device, the execution of the program will also be very slow. So now both the commands and the variables are loaded into memory. So when commands are loaded into memory, they are stored as opcodes. What are opcodes? Opcodes are binary equivalent of the instructions belonging to the instruction set. Okay? They are coded in binary. Okay? Because they cannot be stored in memory like text. Do you follow? They can't be stored in memory like text. They have to be stored in codes. Unlike in the previous architecture, you don't have to load instructions into memory, so there's no need for opcodes. So there are opcodes. Opcodes are binary equivalent of instructions, no? And then there are operands. Every instruction in a store program computer has two parts, no? It has an operand and an opcode. Operand refers to the parameters used by the instruction. For example, when you say load MQ, MQ is the operand. Do you follow? Sometimes when you say store MX, the operand MX is an address in memory. Do you follow? When you say load MX, MX is an address in memory. That's an operand. The opcode is this. Okay? If you count the opcodes, this is 8 bits, no? 8 binary digits. But it's quite long because there is only about 22 or 23 instructions, no? So for 22 or 23 instructions, you will only need 5 bits. Diba? Kasi kung 4, 16 lang. Okay? Kung 5, 32. But in this case, it uses 38 bits. Maybe for future, no? For future improvements where there will be more instructions. No? So however we have load and store, this is equivalent to the L and S. No? L and S cards of the analytical engine. We have special load, no? Meron tayong load minus MX, which means that the value is converted into negative first. We also have load absolute, which means that whether the content in memory is positive or negative, it's removed. No? We also have a load negative absolute, which means that it will force convert the value in memory into negative. And then we have jump MXX 0 to 19 and 20 to 39. There's a jump left and a jump right. Okay? Because the IAS is not a fully vertical computer, no? It's also horizontal. You can jump to the left and to the right. We'll explain that further later, no? And there's a jump plus. This is the nearest equivalent. It's almost identical to the CF and CB of the analytical engine, but there's a subtle difference because the analytical engine will 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 work with 1 minus 1. Do you follow? 1 minus 1 will cause the run up lever to be set. Do you follow? In this case, that's the only exception because a jump plus will only jump if the value in the accumulator is non-negative, which means that it does not include 0. Okay? 0 is a non-negative value. Okay? We have add. We have the plus card, no? We have the plus of the, no? We had add mx, which means add the contents of the accumulator with the value in m of x, no? Add absolute. You have sub of mx, no? Okay? And then uh, sub absolute, which means whatever the sign is, you convert this to positive. You have mul mx multiply div mx. You have left shift. When you left shift binary number, you are actually multiplying it by 2. You have right shift. When you right shift a number, you are actually effectively rather dividing it by 2. We have half stores, no? Store to the left and store to the right. Do you follow? No? We have made a comparison between the IAS and the no, okay, the and the analytical engine. And anyway, to make a long story short, here's the diagram of the analytical engine. Can you see that, everyone? So there are two main components. Previously in Charles Babbage's design, uh, there's only one processor. It's called the mill. Now in Van Neumann's design, he separated the function. He split the function of the processor into two. Do you follow? Do you follow? So there, however, it's the same CPU, no? Okay. So the two components of the CPU are the arithmetic logic unit and the control unit, or otherwise called as a program control unit. Okay. The difference is like this, no? All the arithmetic like plus, minus, divide is done by the ALU. Okay. And the data transfers like load store are done by the program control unit. Do you follow? So that's the main difference between the analytical engine design. In the analytical engine design, everything is done by the mill. Now, during the time of Van Neumann, what he did was to split that into two: a separate unit for arithmetic, another unit for load and store. Okay. So if you have a card reader here, no, the card reader is accessed by the control unit. It can be both directed to the ALU and the program control unit. Okay. So the arithmetic logic unit has the accumulator and MQ. It's like ingress and egress, but with slightly different functions. AC is both ingress and egress. MQ is multiplier quotient. Now, if you are going to multiply the accumulator, the multiplier is an MQ. And the product later on will be saved back to the accumulator. And if you are going to divide the accumulator, the 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 device the rather the yeah the quotient kasi, no, dividend quotient, no, do you follow? When you divide it with a value from memory. Okay. And the result, the quotient will be stored in the queue and the remainder will be in the accumulator. Okay. We have a register called MBR. Okay. MBR, sometimes called the MDR, because in the design, no? If you look at the design of the IAS, other sources will call them MDR. Ito, no? Data register. Do you follow? Data register. But it's also called buffer register. Okay? It stores data from memory. Anything loaded to memory will be temporarily stored to MBR, which means if you are going to divide the accumulator by something from memory, it's stored in the MBR. And we don't have access to the MBR because it's only accessed by the CPU itself. Huh? We don't have access to that. We only have access to AC and MQ. Okay. And then the other component contains the memory address register. First, when you're going to do a load and store, a temporary storage for the address will be stored here. It will not be stored directly to the ALU, or rather accumulator. No? Dito ang address. For example, when you say load 001, 001 is stored here. And then the resulting value will be stored to the buffer register. Okay, do you follow? No, we don't have access. Do we have access to the memory? Yes, because during a load and store, you specify the address. Okay, and then from time to time, no, while the CPU is running a program, it may transfer two types of data. First, it may transfer variables during which the value will be stored to the MBR or MDR or data register, and on another time it will be transferring instructions. No, so instructions will be stored to the instruction register, particularly the opcode, no, that we have in the instruction set. It will be stored here. There's a buffer register for purposes of pipelining. No, it makes it faster. Okay, kung merong pipeline, because it has two instructions being run at the same time. So when it runs the next instruction, it's already ready in the ano. So it's a pipeline concept. But the main but the main register is the instruction register. Okay, they're split into two because the operand goes into the IR and rather the opcode goes into the IR and the operand goes into the MAR. Okay, do you follow? The program counter is the way the CPU controls jumps. Okay, to do a jump, we set the program counter to an address, to a different address, and it will transfer the execution there. Okay, the address in the jump will be stored in the program counter. Okay, it's called PC or program counter, and this is our main memory. Okay, do you follow? Okay, so before we proceed, no, uh, let's look at the IAS, how it looks. Ito, okay, this is the IAS. Let's look at from the main source, no. Several, no. It's the main source, no. Another university comes from American history. Okay, so this is the, no. So yeah, that's the actual machine there. Which part of this I don't know which they are, but to take note, there are vacuum tubes already, oh, vacuum tube relays. So it's already electronic. No? Do you follow? So it's not mechanical, it's electronic. Okay. And it's much smaller than ENIAC. Okay. And people during those time, this is considered a mainframe computer. Unfortunately, it was only used in Princeton College. No? Hindi naman ito, this did not sell. Okay. 1946 to 1951. This is at the same time, almost the same period when EDVAC, the second version of ENIAC, was also produced. No? Do you follow? By Prosper Eckert and John Mockley. Now, if you look at, there's a derivatives of ano, which means what are the other computers that were invented? No, sorry, no, that were developed after the IAS design. Kasi it's like nowadays we have clones, no? They are not exactly clones because they have brands, no? They were owned. Now, itong problema ngayon, this is no longer hindi na ito DNS, no? This is not a problem with DNS, but this is a problem with speed. Grado na ako nito. Kasi we're not lost, we're just slow. So anyway, we'll just go, I'm just going to Google my source, no? Derivatives of the IAS. At sa IAS na lang tayo. IAS computer. In the Wikipedia, it's there, no? Dito naman. These are the derivatives, no? So the known derivatives are as follows, no? We have IBM 701, which has 19 installations. Now IBM later created a computer for online reservation using one of the uh, 701 series. So you can now reserve flights, no? Even PAL is using them. It's a network of computers, no? Connected via telephone lines. Okay? So pwede ka na mag-reserve ng flights. Even during the 1970s, no, 1950s, no? You can, because IBM created them from the IBM series. No? So there were 19 installations. ILIAC also from the University of Illinois. And then Remington Rand. Remington Rand is a company that makes adding machines. Created their version of the IAS. They call it JANYA after John von Neumann, the inventor. John von Neumann Numerical Integrator and Automatic Calculator. Okay, JANYA. There's also CELIAC, no, from Washington, and many others. Now, a very important computer here is EDVAC. Ang EDVAC hindi na nila sinali because it was developed almost simultaneously with the IAS. Ito yung EDVAC ko. Ang nag-develop nito yung nag-develop ng ENIAC. Okay? Do you follow? Okay, so this is also what this was also done in Penn State, University of Pennsylvania, and then this was designed for the military, no? Para pang military to ballistic research. And later on, no, during the 1950s, si Presper Eckert and Mockley developed a third version. It's called UNIVAC. UNIVAC is the same as EDVAC, except that it was not used for the military by the military. No? It was used for the U.S. Census. Okay, so these are the derivatives. Now, which brings us to our main problem. Okay, uh, the IAS programs. Okay, so you can Google na, no? I have updated the links, no? The IAS programs, but I'm going to use my local version because I think it's very slow, no? Okay, okay. IAS programs. Okay, no. First, the fourth factorial, which we discussed earlier, no. Let me just erase everything first. Sayang naman, no? Because yeah, ganun ganun. Okay, we'll erase this. If you compare this to our program involving the analytical engine, this is almost the same. Okay, almost the same, except that this is a stored program. This runs on a stored program computer. So we have a command address. Okay, the address in memory. Do you follow? No? So this is our commands, and this is our memory. And instead of ingress and egress, we only have one AC. Do you follow? This is the accumulator register, both used for ingress and egress. Okay, so we have N004, di ba? So this is the same thing, but this is 001. Ilalagay natin, this is our first multiplier. Our decrement is this. Okay, and our partial product will be in M3. Okay, I think the result is in M4, no? M4 is in M4. Okay, so our partial product will be in N4. Okay, dito. Okay, I don't think M3 is being used, no? But anyway, it's okay, no? It's only one, no? Do you follow? So this is like the fourth factorial that we did in the analytical engine. The first thing we do is compute the partial product and then compute the next multiplier. Two steps, right? So we have load M1. Now, first we have a jump. Why? Because normally when you write a program, all the variables involved in the program are written before the code. Okay? That's what we call nowadays as the data segment. And then the code segment follows the data segment. So that's the tradition, no? It makes sense that all the data comes before so that we can account with make an account of them. Like in a function before, no? In programming languages, you have to declare the function, the variables first at the beginning before using them because they are stored in the data segment. Okay, so our variables come before. And then the first command is a jump to the first instruction in the code segment. This is 5. When you say jump 50019, jump to the left, there should this 5R should be here. But I'm not writing it there because it's very difficult to trace. You know? We just assume that it's here, no? On the right part. Because IAS has 40 bits, but it has 20-bit instructions, no? Which means two instructions can fit in one word, in one portion in memory. Do you follow? Any questions so far? Okay. So a repetition of partial product and next multiplier. So load M1. This means what? Will AC receives, this is the notation, no? M of 1. Okay. There's a data transfer. This is a micro instruction used for as a standard notation, no? For any computer. When you say a data transfer between registers, you have the receives. No? AC receives M of 1. What is M of 1? 4. So AC becomes 4. Do you follow? Okay?
Sir, may question ako, sir.
Yes.
Yung nasa command address good na L and R, kapag
Yes.
L siya, nasa left instruction siya, tapos kapag R, kaya nasa right instruction dapat
Yes.
yan.
Supposedly, ito nandito ito. Supposedly, nandito ito sa right. Ganyan. Di ba?
Mm. Pero yung nasa command address, sir, ano pala dapat nakalagay dyan?
It's the address in memory. Because your memory will have addresses, right? It starts with
Yes.
address 0. Address 1, address 2. Do you follow?
Pero
Computers,
example, sir, like, nandito ko sa row number 8, no? Yung 5L, load M1, store M4. Ano dapat nakalagay dyan? 5 lang or may 5L lang?
now this is the address. What is stored here is load M1. What we say, this is not in memory, ito no? This is not in memory, but this is the address in memory. Because remember, the address will be stored in the memory address register. Okay? This is the address that is stored in the memory address register during the fetch of the instruction. Do you follow?
Yes,
You
sir.
need an address because this time, it doesn't count forward and count backward. It will do a jump. Like for example, when you say jump 5, it will go to the 5th. Ano? Do you follow? Unlike in the analytical engine, you do not jump. You just count backwards or count forward. Right?
Mm.
In the IAS, we don't have a count backwards and a count forward, but we specifically say where to jump. Do you follow? That's why we need 5L and 5R. Because when we say jump 5, 0 to 19, this means this is the left part of 5. Do you follow?
Ay, sir, bakit? Anong meaning ng 0 to 19?
Jump to the left. Which means if you have this as 20 to 39, what does this mean? Jump to the right. So dito siya sa 5R mag-jump.
Mm.
Okay, when this is 0 to 19, it will jump to 5L.
Pero ang gawin, di ba niyan, sir, ang una ma-execute is left, then right, left, then
Not
right?
necessarily.
Hindi ba?
Without the normal sequence, of course, without a jump, okay?
Okay.
Without a jump, if 5L is being executed, the next will be 5R.
Pero
That's
for
why I'm
example, sir,
writing it here. I'm not
nag-jump
writing
ka,
it here. Huh?
nag-jump ka to right. Anong next yung right, sir? Mag-left na siya sa next na line?
Yes, left of the next line.
Oh, okay. Sige, gets.
That's why I'm writing it this way. Do you follow?
Yes, sir.
Kasi pwede namang itong store dito ko ilagay, itong store dito ko ilagay sa right. Do you follow?
Okay, sir.
But the sequence, the linear sequence, that's the difficulty with the IAS because it's not vertical. It's not straight vertical. It has horizontal because it has left and right. But when you write programs, you don't write programs horizontal, right? You write programs vertical. The first command followed by the second, but followed by the third. Vertical, because in memory, they're also stored vertically. Okay? Pero the good news is the modern computers don't have a left and right anymore. Okay? Do you follow? Before we proceed, why is there a left and right? Diba? It makes it a lot confusing because of the left and right. In fact, in the IBM 701, there's no more left and right. Okay? Why not just 5, 6, 7, 8 diretso na lang, no? Why put a 5L? Why put a 5R? If there's no left and right, it could have been easier. But this is the predicament of von Neumann, no? 20-bit is too small for a floating point number, which means you cannot store very large values because this is binary. What's the largest value you can store in 20 bits? Very small. Okay, we'll take that up, no, in our future lessons, no. So for the IAS to be useful, it must be able to compute large and small numbers, no, very large and very small numbers. So it needs 40 bits. Nowadays we are using 64 bits. Do you follow? Nowadays we are using 64 bits. During those times, von Neumann uses 40 bits because precision is also important, which means that it must be able to compute very large values and very small values. So it needs 40 bits. However, there are only 23 instructions, right? For 23 instructions, you only need 5 bits. Okay? Do you follow? So we know now 50 to 19 goes to the left, no? Anyway, that's a question from Guineas. It goes to the left. 0 to 19 goes to the left. Okay? So let's go back. So in 40 bits, you will only need about you have 5 bits and then 12 bits for the operand, less than 20 bits. Most probably you will only need 17 bits. So to make it simple, ginawa na Van Neumann created the instructions to be 20 bits. So if you have 20-bit instructions and 40-bit words, and you are going to make this linear, only half of the word will be used at a time if to store instructions. For data, there's no problem. It will occupy the whole 40 bits. But for instructions, only half of the word will be used because the instructions are only 20 bits. Okay? So what's the issue with that? During those times, memory is very expensive. Do you follow? Memory is like worth a fortune. Okay? It's worth like gold. So it's very inefficient. You have a very large memory, only half of it is used. Do you follow? You get my point? So Van Neumann decided we will put two instructions in one word. Okay? And the efficiency led to complexity of programming. He made it efficient, but he made the programming difficult. Okay, particularly the jump. So why do we have a jump 50 to 19? We say jump to the left. Okay? Meron tayong other jump dito. This is another jump. Jump to the right. We'll have examples which will have jump to the right. It depends kasi kung, it depends on the logic of the program. Okay? Okay? So hindi natin ito matatapos lahat na, but I am extending the assignment to August 9 because we really need to discuss. There's a very subtle difference between the jump in the IAS and the CF and CB in the analytical engine. Because what we are trying to do here is convert the analytical engine program into the IAS, because of course they're just the same program, diba? They're just the same logic, right? No matter what the machine is, the logic is still the same. What logic? We compute the partial product and then we compute the next multiplier. That's how we compute the fourth factorial, partial product and multiplier. So it doesn't matter what language you are using, no, but you mean the same thing. Okay. So when you say it's the same thing in any language, diba? Logic is the same thing in any language. Can we proceed now? Is it clear why it's 50 to 19? Because we want to jump to the left. Okay? Why do we jump until 7? Bakit tayo mag-jump hanggang dito? Because we cannot process the data in between. Right? The CPU cannot process this. Why? Because these are not instructions. This is data. That's the main concept in the stored program concept. Data and instructions will be stored both in memory. No? So that's the main concept of the stored program concept, according to John von Neumann. Okay? Kung sir until 7. Kung till 7, ano dili 0 to 7? This one 0 to 7 because the address of left is 0 to 19. There are 20 bits. Do you follow? So 0 to 19 is 20. 20 to 39 is another 20. Do you follow? Di ba? Kasi hindi naman niya pwedeng sabihin jump left because there's no jump left. Jump right, there's no jump right. There's only jump to an address. Do you follow? When you say jump, jump to an address. Okay? That's why to specify a left, you have to have 0, 19. To specify a right, you need to have 20 to 39. Okay? So let's go back. This is AC receives M1. Okay? The address is like the cell. Yes. One memory cell, one address. Okay? Precisely, no? Ganyan talaga ngayon, no? It's like an array. Memory is like an array where several variables or so many variables can be stored. But this time, we don't just store variables. We also store instructions. Okay? Yun kasi ang concept dyan. Unlike in the analytical engine, we only store variables in memory. Now, in Von Neumann's design, we also store the instructions in memory. So now, our memory will have data and instructions. Unlike if you look at the design of, tingnan natin, no, yung kay fourth factorial in the IAS. O ito, do you follow? What do we see in this part? These are just commands, right? These are just purely programs, right? Do you follow? This is according to Charles Babbage's design. Do we have data here? No. Data is in memory. Nandito sa store. The variables are in memory. So, the variables and memory are in two separate places. Do you follow? So, in those times, no, 1950s, the main source of input are the card readers. So, these are placed in the card readers and the values are placed in memory. But according to von Neumann, that's not good, no? Excuse me a while, no? I'm sorry, no, for the disturbance. So that's the main concept there, no. In the IAS, our program is now, our program and our data are on the same memory. Do you follow? So itong program na to, we also have data here. We are just showing the memory here so we can trace the values. Do you follow? No? Do you follow? Okay. Let me proceed now. So we have jump 5, 0 to 19. This means it's a jump left. Okay, so dito sa 5 left. Okay, so we begin our program here. Okay. So now, anong ibig sabihin ng load M1? AC receives M1. What is M1? 4. Okay, so the AC becomes 4. Okay, follow? And then we have store M4. It's like S, no? Store M4 means M of 4 receives AC. You follow? Which means the value of 4 will be stored to M4. This is our partial product. The first partial product is 4. You follow? The second partial product is 4 times 3. Okay. Sub M2. Why do we sub? Because we will compute the next multiplier. Okay. What does sub M2 mean? Sub M2 means AC receives AC minus M of 2. Do you follow? Okay. This means now you see the purpose of the accumulator. It's used as an input, it's also used as an output. Ingress and egress. Okay, do you follow? What's M2? M2 is 1. Okay, so the actual result, the actual content here is 4 minus 1. Okay, so this becomes 3. The accumulator becomes 3. Okay, do you follow? Okay, so 3 is our next multiplier. We store it as the next multiplier because our next multiplier is an M1. So we say store M1. What do you mean by store M1? M of 1 receives AC. Actually, we already have it here. So M1 now becomes 3. So the next time we multiply with 3 instead of 4. Do you follow? So we have computed the first partial product. We have computed the next multiplier. What's the next thing to do? Repeat. Okay. Compute the next partial product. We have mul stands for multiply. AC receives AC times M of 4. Do you follow? So what's M of 4? It's currently 4. AC is 3, no? Currently 3 times M of 4 is 4. So that's the actual content. So AC will now become 12. 3 times 4, okay? Do you follow? We have computed the next partial product. We are going to store it back to M4. So we say store M4. Store M4 means M of 4 receives AC. We already have it here, so we just copy it here. Okay? M of 4 receives AC. So what happens that is this becomes 12. Okay? Do you follow? Okay. I hope mahabol ko yung 3 o'clock, no? Kasi, anyway, we'll do the rest faster, no? Load M1. Kasi I have covered a lot during the earlier session this morning. Okay. 3 times 4 store M4, that's right. Load M1. What do you mean by load M1? Anybody? Ito, load M1, AC receives M1. We'll just copy it, no? Do you follow? AC receives M1. What's M1? It's 3. It's clear, no? 3 ito. Ito siya. So AC becomes 3. Okay? And then we sub M2. What do you mean by sub M2? Ito, AC receives AC minus M2. So AC is currently 3. M2 is 1. So 3 minus 1. So AC becomes 2. Okay? And we store it to M1. Okay? Store M1 means M1 receives AC. Like egress. Diba? Parang egress siya. Okay, so magiging 2. The next multiplier is 2. So we're done with this step. So we repeat again. Okay, we compute the next partial product, load M4. What is load M4?
M4 goes to AC.
M4 goes to AC. Meron na ba tayo dito? Load M4. Wala tayong load M4. So ito na lang. Okay, ito na lang. M4 goes to AC. So AC, and then we'll change this to M4. Okay. So load M4, M4 goes to AC. What's M4? It's 12. Okay. Mul M1. Meron na ba tayong mul M1? Wala pa. Meron tayong mul M4. We'll just change this. Mul M1. So this is now, what do you mean by this? Multiply AC with M1. So AC is now 12. What's M1?
2.
2. Okay, good. So AC becomes 24. Do you follow? And store M4. That's why again AC goes to M4. So now M4 becomes 24. Our final answer will be in M4. Do you follow? No? Do you follow? Load M1. So meron na tayo ito. AC receives M1. Dito. Diba load M1, it means AC receives M1 or M1 goes to AC. What's M1? 2. Now we are doing this to compute the next multiplier. Okay? Sub M2. So AC receives AC minus M2. Ito, we already have it here. Okay, meron na tayo nito. Okay? Okay? So sub M2 means 2 minus 1. Right? So the AC becomes 1. And we store to M1. The AC goes to M1. Okay, what's M1? It's now 1. Okay, do you follow? Everyone? Repetition, no? We have computed the next multiplier. We repeat the process. We compute the next partial product. Load M4. We already have it here. Load M4. AC receives M4. Meron tayo? Bakit wala tayong load M4? Meron tayong load M1. Okay. So load M4.
Ay, meron nata sir sa 17, di ba?
Meron na ba? Sige lang, ito na lang. Gawin na lang natin ng M4.
Okay.
Di ba? It's the same thing. No, baligtad. AC receives M4. Ito. Load M4 man. Okay? So that's why, no? Okay. What is M4? 24. Okay? So dito siya papunta sa AC. 24. Okay? Mul M1. So we have mul M1. AC receives AC times M1. So the actual content. What's M1? 1. So the actual content is 24 times 1. Do you follow? So the result is 24. Okay? And we store M4. So we have M4 receives AC. Okay? So our final value is 24. And then this one is a halt. Now we don't have a halt command. What we'll just do is loop to that perpetual. This is a perpetual loop which will do nothing. Do you follow? No? Do you follow? So I'll upload this, no? So it's a repetition of computing the partial product and computing the next multiplier. Okay. So look, if you have done that JavaScript or Python, it's much easier, no? But if you're doing assembly language, you have no such convenience, no? Because yeah, we will have a lot of load and store, no? Of machine language. Do you follow? Fahrenheit to Celsius, let's do this quickly, no? So ito na ngayon. Jump 6, 0 to 19. Why 6? Because we have 5 variables. Do you follow? The first variable is the variable we convert. We have a constant 32, a constant 5, and a constant 9. And the result we store in M5. Okay? So I'm not going to erase this anymore. Load M1, so AC receives 132. And then we have sub M2, we subtract 32. So AC becomes 100. And mul M3, M3 is 5, so we multiply by 5, 500. And then div M4 divided by 9. And then we store it to M5, which is the final result. Okay? And then we do a halt. Do you follow? Okay? Now, look at the jump here. It's 20 to 39 because we happen to fall on a right part. Do you follow? It depends on the logic. Sometimes it falls to the left, it falls to the right. It needs to fall to the right, okay? Do you follow? This is the conversion of meters to feet. We have 4 meters. We multiply by, so load M1. Then we mul M2, which is 3.28, and we store M3, and we'll have a halt.
Ay sir, may question ako sir.
Yes.
Asan ang print dyan? May print tayo na
Wala tayong
option.
print. There's no print in the instruction set. That's the problem, no? That's one of
So
the problems.
kapag like final answer yung hinahanap, kung anong nasa AC lang answer?
Depende, yes, it's always on the AC, no? Or on a designated portion in memory. Like in this case, our final answer is in M3, but it's also in AC. No?
Oh, okay.
Okay. This 20 to 39. So halt. Let's look at the Fahrenheit to Celsius. The final value is in AC also. Diba? The fourth factorial, the final value is in AC. Okay. Do you follow? Okay. Now, we will try to do the loop and we will find out. We still have time, no? Hanggang 3 o'clock tayo, di ba? And I will introduce a problem that you will need to solve. I have solved it already. No? It requires a programming concept. Now, the main problem we have when we are going to convert this into a loop, our fourth factorial, it's easy, no? We can adapt. We can adapt the program we had for fourth factorial sum and average, di ba? Dito, ito, average with loop. Okay? Fourth factorial with loop. Meron ba tayong fourth factorial with loop? Wala. But we can use the same process, right? But we have a problem because a CF and a CB, do you follow? A CB is not an exact equivalent of a jump plus. Okay, let's look at the documentation so we can get to find this out. Ito yung main difference nila eh. Okay, a jump plus will only jump if the accumulator is non-negative. Okay, that's the main problem. Now let's go back to the analytical engine. Okay, so ibig sabihin, if you have a 1 minus 0, that's a 1. If you have a 1 minus 1, that's a 0. Will a jump plus work on a 1 minus 1? No, because 0 is not a non-negative. Do you follow? Now, dito on Charles Babbage, no? 1 minus 1 will work. Do you follow? Di ba? 1 minus 1 will work. Because it will not set the lever. Jump if set man yan, di ba? So, if you are going to convert this into a program, we will not have a problem with 1 minus 4, 1 minus 3, 1 minus 2. When we reach 1 minus 1, the analytical engine will work, but the IAS will not. Do you follow? And we will have a problem. Okay, we will have a problem, but anyway, programming is an art, no? So somehow, no, we can still make a program. In fact, we can even make a simpler program, no? I will introduce techniques, no, in looping next meetings. You're studying, di ba? You're taking up intro to programming, right? Aren't you this semester?
Yes, sir.
So most probably you will reach looping also. Di ba? When you do looping, you will have looping at you have a head, you have a tail. You can do a condition at the top or condition at the bottom. You will have a condition for continuation or condition for termination. So with all those things, no, you can transform a program for programs like this, like factorials and sums and averages. Okay? Meron pa tayong oras. Let's do this quickly, no? Let me look at the IAS factorial program. Ito, version 1, okay? Okay. So, this is a loop ito with loop version, but this is still the same thing. First, we compute the partial product, then we compute the next multiplier, which is 3, and we check if it's a positive. If it's still positive, we repeat. Okay, this is a conversion of the program from the analytical engine. Okay, conversion lang ito ng analytical engine. Okay, do you follow? Okay, can you see the Can you see the whole program? So ito yon. This is our first partial product. Okay, this is our decrement. This is our first this is our loop indicator. No, do you follow? If this reaches 0, we will stop. Okay, loop counter. 4, I think, is left vacant. No. Okay, any questions? Let's do this quickly. Okay, mabilis lang ito, no? So load M1, we have AC receives M1. So AC receives 4. Mul M3. So the actual are 4 here. So what do we have here? We have AC receives AC times M of 3. So this is actual AC is currently 4. The actual content is 4 times 1. Diba? And AC becomes 4. Okay? You follow? And we store M1. which is our next, no, which okay, which is our next partial product. Okay, this is our first partial product. Okay, so actually by store M1, I hope I can palitan ko lang, no. Sorry, it's too small. Okay, can you still see it? Makita lahat, no? By store M1 we mean M1 n of 1 receives AC. AC goes to M1. So ngayon nandito na ngayon. Okay. So we have computed the first partial product, which is 4. So what we're going to do is compute the next multiplier. We load M3. AC receives M of 3. Do you follow? So what is M of 3? M of 3 is, what's M of 3? It's 4. Do you follow? No? M of 3 is 4. Okay, so this becomes 4. We sub M2. So AC receives AC minus M of 2. Sorry. So what is AC now? It's 4. So the actual content is 4 minus 1. Okay. So this becomes 3. Let me erase this first. Ayan na lang, no? Store M3. M of 3 receives AC. We'll just copy this. This is M of 3. So nandito na ngayon sa M of 3. Okay. And then we jump plus 60 to 19. Okay, diba? This is the concept we adopted from our factorial program in the IAS. This means that we look at the AC, right? Is it a plus? Jump plus. Is it a plus? Yes, it's still a 3. So if it's still a 3, we will repeat to the 6 to 6L. If it's not a jump plus, it will go to 9R. It will just halt. Do you follow? Do you follow, everyone? No? Which means that since it's a 3, it's a plus, so we will repeat to pass 2. So sa pass 2, ganun pa rin, di ba? I'm not going to erase it anymore. I'm running out of time. So basta ang last nating value is 413. Okay? So we load M1 to AC, so it becomes 4. And we mul M3. M3 is now 3. 4 times 3 becomes 12. And we store M1, so our partial product becomes 12. And then we compute the next multiplier. We load M3, it becomes 3. Sub M2, 3 minus 1, it becomes 2. We store it to M3, it becomes 2. And then we jump plus. What is the AC? It's a plus. So we will repeat to a third pass. Do you follow? Our values being 12, 1, and 2. Okay? Do you follow? So third pass tayo. Load M1, so magiging 12 ito. Mul M3, M3 is 2, so 12 times 2, 24. So we have stored it to the partial product, 24, our next partial product. So we have computed the partial product, we will compute the next multiplier. So load M3, M3 is 2. We sub M2, 2 minus 1, it becomes 1. Store M3, it becomes 1. Jump plus. Is this a plus? Yes. So we still repeat, pass 4. Dito tayo magka-problema ngayon. Kasi sa 1 minus 1, makaubo ta rin. So 1 minus 1. Okay, our values being 24, 1, and 1. So load M1, 24. Mul M3, 24 times 1, 24. Store M1, it becomes 24. I hope you're following now. I'm just repeating it now. I have to go fast because I'm running out of time. Sub M1, 1 minus 1, 0. Okay, we store M0. Jump plus. Okay, jump plus. Is it a plus? Yes. So we'll go back one more time. This is the problem. This is where the problem lies. No? Because for the IAS, when we say CB will work because 1 minus 1 will not set. So which means it will just go on to 9R. It will skip this, it will go to 9R, and then it will just halt. Right? Do you follow? But in this case, 1 minus 1 for the IAS will not work. It will still repeat. Do you follow? So we will have a pass 5. We'll have a pass 5. So we have 24. Now our next multiplier is a 0. So 24 times 0, it becomes a 0. Okay? So dito sa M1, magiging 0 na ito. Do you follow? And then we load M3. What's M3? This is a 0, right? And then sub M2, we will have a 0 minus 1. 0 minus 1. And now this becomes a negative 1. And store M3, this becomes a negative 1, right? Jump 6 to 19. Will we still jump 6 to 19? No more, because this is now negative. So we will go to a halt dito. Okay? We were able to finish the loop, but our answer is wrong. Our answer is 0. Do you follow? In fact, our last AC is negative 1. Do you follow? Wrong answer. Okay? Why? Because we should have stopped here. When we stopped here, okay, and our final answer here is 24 should have been correct. Tama na itong 24 dito. Do you follow? And that is because there's a subtle difference between jump plus and CB. Kasi ang CB mag-work with 1 minus 1. But jump plus will not work with 1 minus 1. Okay? Take note, no? Ito sasabi ng ano? Okay? 1 minus 1 will not set the lever. So therefore, it will set here for the analytical engine. The problem is, what's the problem? Bakit hindi ginawa? Why didn't Van Neumann just created it exactly the same? Do you follow? Why did he create it exactly the same? I don't know. Okay? They just don't like to follow. Okay? But nowadays, no, we have a lot of jumps in the IBM PC. No? We will not have problem if you are, no, let's Google that, no? Jump instructions. Or Intel machines. Let's say 8088. It still works. Okay? Ito yung jump instruction sa ano. Okay? One is J and Z. Jump if not 0. Okay? So which means positive or negative, it will jump. And then JG. JNLE. Jump if not less than or equal to. Diba? Or it's just like a JG. What's a JG? Greater than. Okay? Jump if greater than. Okay? So, or it's also JNLE. There's also a JA. Jump if above. Which means it's above 0. It's positive but it's not 0. Do you follow? So, there's also a JAZ or a JE. JZ means jump if 0. Okay? JE, jump if equal. Okay? There's even a CMP. So JG, jump if greater. There's a JAZ, jump if above and 0. So ang dami ng jumps. Okay? They supplied all the different jumps, no? All the jumps later just to make programming easier. Do you follow? Do you follow? Even in the other processors like Motorola, it has a lot of jumps. That was because during the IAS, there's only one jump. Okay, there's only jump plus, and it's very difficult to program if you only have one jump. Do you follow? Do you get my point? Okay. So ngayon, ang dami ng jump ngayon. There are so many jumps. There are more than 20 jumps in the IBM PC. Okay? JA, JAZ, JN, JG, JNLE, jump if not lesser than or equal. Ang daming jumps. Okay? They follow because in the past, people didn't like the jump plus actually, no? The jump plus is very difficult. If you only have one jump, na jump plus lang, programming is very difficult, okay? But anyway, we can solve this, okay? I will introduce new concepts in looping my next meeting. I haven't done the material yet, but it's not difficult. Okay, there's a way. If you are going to force this issue, i-force mo yung issue using the CF or CB, you can never create the program right, because jump plus and CB are not the same. Do you follow? You have to apply different techniques. Any questions so far? Okay. Okay. So I will not have a class. Remember, now next week we will only meet on August 3. Okay. Next week we will only meet on August 3. Please don't forget, no? Baka hindi na ako mag-email, no? Okay, everyone, because by August 5, I'm doing an orientation to the newcomers. I don't know how many they are. Okay. See you next meeting. Did I miss anyone? Let me check, no? Aranyas, are you there? Aresa,
Sir, present si Aranyas, sir.
Aranyas,
Yes, sir.
Areza. Do you have Espinosa? One is in the second batch. Paraiso.
Present, sir, present.
Pulido, I'm not sure where he is right now, no? Recto. Rika. Tanduyan. Now, people from the second batch are still in their other school. Okay? Kasi ano pa ngayon, no? We started early, classes early. So, yeah. People in the second batch, some of them have just graduated senior high. Okay?
Present ako, sir.
Sino yan?
Rowan, sir, Rowan. Tanduyan.
Rowan. Tanduyan. Okay. Anybody else? Okay. So those who are late, you can see that I'm going to upload the video. Okay. So see you next meeting, August 3. Okay. Bye, everyone.
Bye, sir. Thank you, sir.
Bye, sir.
Bye, sir.
Thank you.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you.
Sir, my question po ako last.
Yes.
Aside po next week, twice a week lang po talaga tayo mag-meet.
Yes, twice a week lang tayo, no? The lab, except if there's a need to do for us to do laboratory work online, okay? For the moment, I'm going to give you assignments, okay? Do you follow?
Thank you, sir.
Okay. For the moment, you're going to do your assignments during your lab time. Allotted lab time, okay? Okay. We will have lab times, no, when we do programming. Do you follow? When we reach the later part, especially on HTML, no, and JavaScript. So we'll be spending, and I will tell you, no, okay, when we will have our lab. Okay. So am I clear? No? Okay, so see you next meeting, everyone. Thanks for coming, and bye. If you have questions, you email me, okay? Thank you.